So what is the primary purpose of annealing heat treatment process? So annealing is basically an post heat treatment process. It's basically done to relieve the internal stress and improve machinability. As you will, okay, when you look at the notes of metallurgy, you could see what is annealing. The basic thing is to relieve internal stress. So where does this internal stress come from? Now after cold working, the material would concentrate internal stress. It would have internal stress, so you have to relieve it, you have to remove it. So annealing is basically the post treatment of first process in order to relieve that internal stress, and it would improve the machinability. Okay, which factor does not influence the formation of martensite in alloy steel? Okay, you have to choose the factor which do not influence the formation of martensite. First one is cooling rate, then presence of alloy element, ambient temperature during cooling, and initial carbon content. Okay, so let's discuss the factors which affect the formation of martensite in alloy steel. Okay, then we could pick out the one that do not influence. So what are the factors which influence the formation of martensite? So the first one is cooling rate. So martensite forms when steel is cooled rapidly. So martensite is basically formed when quenching. I mean, rapid cooling is called as quenching from the austenite phase. Okay, when we study the GTT diagram or any diagram, we are considering the cooling down from the austenite phase or that gamma phase. Okay, from that below the eutectoid point or below the lower critical temperature, we will get different varieties of steel based on the composition. So, so martensite is basically the rapid cooling. Okay, suppose we have an steel is in austenite phase, full of austenite phase, no other phase present, and I am suddenly cooling it. Okay, sudden cooling, rapid cooling, quenching. What do you get? You get martensite. Okay, I remember that. So we are cooling, right? Suddenly cooling. So it really it's a factor for formation of martensite. Okay, high cooling rate is essential to support diffusion control and like perlite or bayonet, and allow the diffusionless transformation to martensite. Okay, so of course it's a rapid cooling. It is one of the factor for formation of martensite cooling rate. Next one is presence of alloy element. So alloy elements such as chromium, nickel, molybdenum, which increase the hardenability of steel. Okay, make it easier to form martensite by slowing down the formation of other phases. So if you ask this, add this alloy element like chromium, nickel, what we really get the end product as, it would reduce the formation of other phase product during cooling. Okay, so simply we get martensite. So presence of this alloying element would actually help for the formation of martensite. Okay, so presence of alloying element is also a factor for the formation of martensite. And final one is the carbon content. Okay, carbon content is it would really significantly affect the hardness and stability. More carbon content, it would be more harder, right? So higher carbon content increase the hardness of the martensite and influence the temperature range. So carbon content is also one of the factor for formation, one which affect the formation or the amount of strength, hardness for a martensite. So obviously these three are the factors. So among that, the ambient temperature during cooling will be the factor which do not influence. What is the primary effect of the tempering process on a martensite steel? Okay, what is the effect of tempering process? First one is to decrease the ductility by increasing hardness. Then it increases both ductility and corrosion resistance. Reduce the hardness while enhancing the toughness, and it stabilizes the dimension of the steel. So what really does tempering process influence on a martensite steel? So let's look at it. So what exactly is a tempered martensite? So a martensite, in addition to being very hot, is so brittle that it cannot be used for application. So we know martensite is harder, right? We already discussed the factors influencing. The previous question was the factors influencing the formation of martensite. We already discussed the more the presence of carbon content, it would really affect the hardness, or it would become more hard. Yeah, it would obviously become more harder, but on the other hand, it will become brittle. So you cannot use it for any other purpose. So in addition to that, also any internal stress that may have been introduced during the conching have a weakening effect. The one thing you have to keep in mind is that the conching, whatever is conch, it would have a weak strength. We are rapidly cooling down to a very low temperature. It will be brittle and it will be having very weak strength. Of course, it will be hard. Obviously, it will be hard, but it will be weak. Okay, hardness cannot be in metallurgy. You cannot. Normally you say hard material, strong. In metallurgy, you cannot say harder or the strongest one. You should understand the term exactly like it mean in metallurgical term. Okay, so harder material will be somehow brittle. Okay, based on what type of process is involved. So when it is harder, we cannot say it is unbreakable or highly strength. Suppose here we know martensite is suddenly formed due to sudden conching. So obviously it will become harder, but on the other hand it will be brittle and weak. So it could suddenly break. That's what that sentence is explaining. So that rapid conching will have a weakening effect. So ductility and toughness of the martensite may be enhanced, and these internal stress relieved by heat treatment known as tempering. So tempering is obviously this sudden uh, what conching would cause some sort of internal stress to form inside the body, and because it is already in the brittle stage, so have to remove that brittle nature to make it somehow stronger. So that post conching process is basically tempering, not to increase strength. So the tempering process, heat treatment applied to martensonic steel, right? Martenstic steel, and it would really have some effect after tempering. Okay, we are doing tempering because of the brittle nature, not to remove that. But what happens after tempering? The post effect of tempering. So reducing hardness. Okay, tempering reduces the extreme hardness of the martensite, which can make the material too brittle for a practical use. Okay, it would obviously reduce the hardness. The hardness was the one that keep it so brittle and not practically usable to anything. So obviously this tempering process would reduce its hardness, and it would make less brittle. Okay, and enhancing toughness. Okay, by reducing the brittleness and increasing ductility, uh, it would increase ductility. This tempering process basically it improves the ductile nature. So hardness is reducing, we are reducing brittleness, ductility is increasing. So tempering improves the material's ability to absorb energy and it resist fracture. So among these options, option C it would be the suitable answer. It reduces the hardness while enhancing toughness. Okay, all other is not possible. Okay.